Hello students. So in this session we will discuss about iterating arrays element. So beta iterating means traversing through elements of array one by one. Means we have to travel through the array by traversing individual element. Okay, one by one. So we are having one dimensional array, we are having two dimensional array. So for this we are having a for loop in Python for iteration array elements. Okay, so first we will discuss how to do iteration in one dimensional array, then we will discuss how to do iteration in two dimensional array. So here we are having a one dimensional array and the elements are 1, 2 and 3. So if we want that we get each element of the array, then beta very simple, we have to use the for loop. Okay, so let me do it for you. So suppose beta we are having one dimensional array, then what we will do, we have to access each element of the array. So for that we are having beta for loop. So for x in array, name of the array, and when you will write print x, it will give you individually all the elements of the array. So that is the simplest way we can iterate through one dimensional array. But what happens in case of 2D array beta? Since in case of 2D array we are having the elements in the form of rows and columns, then here two for loops are needed. Why two for loops are needed beta? One to control the number of rows and another one to control the number of columns. So here the outer loop will take care of the row and inner loop will take care of the column. So here you will have all the elements individually one by one. So we will get the output 1, 2, 3, then it will start the second row, then 4, 5, 6. So here we are having the output. Okay, the next topic is beta we are having arithmetic operations. What are the operations that can be performed on our NumPy array? So all the arithmetic operations can be performed, but we have to remember one thing, that if we are going to add two arrays, subtract two arrays, multiply two arrays, or any arithmetic operations we are going to perform on two arrays, then the two arrays must be of same size. Okay, because here we are having element wise operations, we have to perform element wise operations. So for that, size of two arrays are needed to be same. So we can perform plus, minus, multiplication, division. Apart from that, we can perform power operation also, exponent, then modulus also. So let us see how to write code to perform all these arithmetic operations. Here we are having, I have taken beta two one dimensional array. You can take two dimensional array also, it will perform similarly. So what I have done here, for plus, for minus, for multiplication, for division, this is for exponent, what it will do, individually all the elements will be added, corresponding elements will be added, corresponding elements will be subtracted, like that. So here the array size must be same and you will have the output like this. This is for what beta? This is for exponent. So array 1 to the power array 2. So here 1 to the power 4 will be 1. See here output. Okay, then 2 to the power 5 will be 32 and 3 to the power 6 will be 729. So all the operations will be done to the corresponding elements. Okay, similarly it can be done for two dimensional array also. Then next one is beta transposing. The transposing word means if all the rows of array becomes columns and all the columns of the array will become row, then it is known as transpose of matrix. Means interchanging rows and columns of 2D array is known as transposing. So for that we are having a function named as transpose, which will do this interchange. Now see how to use the transpose function in our code. What we have to do here, now see, I'm having two dimensional array as this one. So before transposing I have displayed it. This one is 1, 2, 3, 4, 5, 6, and when we will call the function transpose, then the output will be this one. Means now see, the row was 1, 2, 3. Now row has become column 1, 2, 3, and the second row has become the second column. Okay, and the columns have become row. In the first column we were having 1, 4, and in the first row we are having 1, 4. So all the columns will be interchanged by rows and rows will be interchanged by column. This is known as transposing, and for this we are having the function transpose. Next one is sorting. Sorting, in NumPy we are having sort function which will arrange our elements in ascending order. By default it will arrange our elements in ascending order. Okay, so both one-dimensional array and two-dimensional arrays can be sorted. So if we are using one-dimensional array, before that let us see how to use the function sort. Here you have to write it using np.sort, and you have to pass the array which you want to be in sorted order. So here I have passed an unsorted array, and see the output, the array has been sorted in ascending order. Okay, now 2D array can also be sorted. So 2D array, for it, now here we can sort 2D array in two different ways. First one is in row wise order and second one is in column wise order. So if we are not mentioning the axis, the sorting will be done row wise, but if you want it to be done column wise, then you have to mention here axis equal to 0. Okay, now see here, when we have written np.sort array only, we have written. Now here see that, let me execute it once more now see here row wise sorting has been done. Means first this row has been sorted in ascending order, so elements have become 2 3 6, and then this row has been sorted, then elements will become 1 6 9. If we want to perform it column wise, then we have to mention axis is equal to 0, and for that we are having, now see, first column has been sorted, so 1 and 6, then this one 2 and 9, it will remain as it is because already sorted, then 3 6, it will remain as it is because it one is sorted. Okay, so this one all about NumPy iteration, sorting, and one thing more we are having descriptive statistics in NumPy also. Means we can calculate sum, we can calculate max, mean, all these statistical operations can be also performed in our NumPy. So how to do that it is again very easy. Suppose I have written here some function, it will give you total of all the elements of the array. See, now if you want to find the maximum value of your element, you have to write here max. See, it will give you the maximum value. Then if you want to find the minimum, you have to write here mean function. Then if you want to find average, then you have to write mean function. Okay, so like this you can perform all the descriptive statistics of the values in NumPy. So I hope you have understood all these concepts, So thank you for watching.